We need to stop lying to ourselves. For the past 5 years, Western automotive media has treated the Chinese EV industry with a mix of arrogance and condescension. They called their cars appliances. They said they lacked character. They claimed they could never match the engineering heritage of Porsche, the luxury of Mercedes-Benz, or the racing pedigree of Ferrari. They were wrong, completely wrong. What we are witnessing right now with the Vision GT concept and the SU7 Ultra is not just another product launch, it's an ultimatum, delivered directly to the global automotive establishment. Think about how absurd this situation really is. Xiaomi was, until very recently, best known for making smartphones, air fryers, and electric scooters. They had 0 years of automotive manufacturing history, no heritage, no racing legacy, no trophy cabinets filled with decades of victories. And yet, in just 3 years, less time than it takes some traditional manufacturers to finalize a door handle design, they built a manufacturing ecosystem that makes established automakers look painfully outdated. What you're looking at with the Vision GT concept is something that barely looks like a car at all. It looks more like a spacecraft designed for another planet. The concept boasts a theoretical output approaching 1,900 horsepower and features active aerodynamics so aggressive they would likely be banned in professional racing. Many critics dismiss it as just another unrealistic concept, a digital fantasy, vaporware. But they're missing the point entirely. The Vision GT is not just a dream, it's a demonstration, a statement of capability. It showcases an underlying architecture that already exists in production form today. The technology required to build something like this, hypercasting, advanced alloys, and structural battery integration, is already operating at scale inside Xiaomi's factories. This isn't really about a concept car. It's about the industrial transformation required to produce a chassis that is lighter, stronger, and more rigid than anything built using traditional manufacturing methods. To understand why Xiaomi has unsettled so many established automakers, we need to leave the design studio and step into the metallurgy lab. One of the biggest bottlenecks in modern electric vehicle production is the chassis itself. Steel structures are strong but heavy. Aluminum structures are lighter but expensive and difficult to manufacture at scale. Tesla attempted to address this problem with large-scale aluminum casting, injecting molten metal into massive molds to create large single-piece components. It was a revolutionary idea, but it came with a major limitation: heat treatment. When aluminum is cast into large structures, the internal grain structure can be weak and brittle. To strengthen the material, manufacturers typically heat treat the part, aligning its crystalline structure and improving durability. But heat treatment introduces another problem. Large metal components tend to warp and deform when heated, reducing dimensional accuracy. Engineers are forced into a difficult compromise: a part that is straight but weaker, or a part that is stronger but slightly distorted. Xiaomi refused to accept that compromise. Instead, they concluded that existing alloys simply weren't capable of meeting their requirements. So they took a different approach. They created a new alloy altogether. Rather than relying on traditional experimentation, Xiaomi used artificial intelligence. They developed a deep learning simulation platform capable of analyzing millions of alloy combinations. The system evaluated different mixtures of aluminum, silicon, magnesium, and trace elements, simulating their structural properties and behavior under stress. After countless simulations, they arrived at a new material: Titan alloy. This proprietary die-casting alloy offers high strength and high ductility, allowing it to withstand extreme loads while maintaining flexibility. But the most important characteristic is what it doesn't require: no heat treatment. The material comes out of the molds dimensionally accurate and structurally sound, ready for immediate assembly. While traditional manufacturers continue welding together dozens of individual parts and hundreds of welds, Xiaomi has used artificial intelligence to fundamentally rethink how automotive structures are built. This material innovation is one of the key reasons why the SU7 Ultra can handle extreme loads and stresses without structural compromise. Of course, material alone isn't enough. It also requires the right manufacturing process. In the world of die casting, size matters. The larger the casting machine, the larger and denser the components it can produce. Tesla's large casting machines were once considered the practical limit of the technology. Xiaomi pushed beyond that. Their hypercasting machines operate at enormous clamping forces, injecting molten metal into precision molds at extremely high speeds. The rapid injection helps prevent air pockets and internal defects, ensuring structural consistency. The result is dramatic simplification. Components that once required dozens of individual parts and hundreds of welds can now be produced as a single piece. Fewer parts mean lower weight, fewer failure points, and faster production times. Quality control is also heavily automated. Advanced scanning systems inspect each component for defects before it ever reaches the assembly line. This approach results in structures that feel exceptionally solid and rigid, a characteristic often associated with high-end performance vehicles. But the innovation doesn't stop with the chassis. One of the most significant engineering decisions in Xiaomi's platform is the way the battery is integrated. In many electric vehicles, the battery is treated as a separate component, essentially a heavy box mounted beneath the floor. Xiaomi takes a different approach with structural battery integration. Instead of simply mounting the battery pack, it becomes part of the chassis itself. The battery contributes to the overall strength and rigidity of the vehicle. This approach reduces weight while increasing structural stiffness. The result is an extremely rigid platform. To put that in perspective, torsional rigidity is one of the key indicators of chassis strength. Higher rigidity improves handling precision and suspension performance by minimizing unwanted flex. A highly rigid structure allows the suspension components to operate more effectively, improving both ride quality and performance. This level of structural integrity becomes especially important when dealing with high-performance electric drivetrains. Electric motors produce instant torque, placing enormous stress on the chassis. Xiaomi developed high-performance electric motors capable of extremely high rotational speeds, allowing them to produce significant power from relatively compact units. In high-performance configurations, multiple motors can work together to produce extraordinary levels of output. Delivering that kind of performance requires a structure capable of handling extreme forces without distortion. This is where the combination of advanced materials, structural integration, and large-scale casting becomes critical. Each element supports the others. Material science enables manufacturing. Manufacturing enables structural rigidity enables performance. This is systems-level engineering, and it's happening at remarkable speed. Meanwhile, established automakers are facing significant challenges adapting to this pace of change. Many have invested heavily in existing production systems and supply chains. Transitioning to entirely new manufacturing approaches is both expensive and time-consuming. That creates a difficult situation. Moving too slowly risks falling behind. Moving too quickly risks massive financial losses. It's a classic example of technological disruption. The Vision GT concept isn't just a design exercise, it's a signal. It demonstrates what becomes possible when advanced materials, automated manufacturing, and electric drivetrains are developed together as a unified system. The SU7 Ultra shows that these ideas are already moving from concept to reality. Manufacturing is accelerating, technology is evolving, and the industry is changing faster than ever before. For consumers, this transformation could mean better performance, improved efficiency, and more advanced vehicles. For legacy manufacturers, this represents a serious challenge. The future of automotive engineering is being rewritten in real time, and this time, the competition is global.